Hello, and thank you for joining us today. I am Dr. Valerie Shoup, and I'm here with my business partner, Michael Fladmar. We are owners of Sustainable Systems of Texas, also known as SST. We provide sustainable equipment solutions to our customers. Also joining us today is Brian Rogers. He is with TransPower Company. We would like to share information today on power quality. We believe you will find this information compelling. So what is power quality? Today we will discuss electrical power quality, common power quality problems, causes of power quality problems, why you need good power quality, the current technologies to address power quality problems, and the most recent technology, maximum power transfer solutions, also known as MPTS. Maximum power is transferred when the internal resistance of the source equals the resistance of the load. Professor Moritz von Jacobi of St. Petersburg, Russia, experimented with electrical motors and built an electric boat for excursions on the River Neva. In the course of these experiments, he considered how much power he could get out of a battery. During the course of his research, he developed maximum power transfer theorem, which states maximum power is transferred when the internal resistance of the load of the source equals the resistance of the load. In 1890, passive filters were introduced for transmission systems. Electrolytic capacitors were patented for AC motors in 1910. And in 1956, Bell Labs introduced solid-state MOSFETs to the market. With the introduction of variable speed drives in 1959, system harmonics became more prevalent. So in 1971, active filters became widely used to mitigate harmonics. In 1992, the Department of Energy implemented the energy efficiency ratings for motors, better known as EER. So in 2001, the maximum power transfer solution, or MPTS, was discovered, finally solving Jacobi's law from 1840. Originally, the research team used MPTS as a solution for single ballast lighting. Then with the advent of LED lights, it was determined that MPTS should be developed to provide power quality solution for whole building systems. In 2008, the MPTS was patented in 28 countries. In 2013, the system became UL certified, and in 2017, version 2 became commercially available. So what is power quality? It's synchronization of voltage, current, frequency, and phase. So Michael, what are some common power quality problems?
Thanks for asking, Valerie. So let's review this list that you see on the slide here. These are the most common problems that you maybe have experienced in your facilities. So a brief description for each of these, starting with voltage sag or dip. And this is a decrease of the normal voltage level between 10 and 90% of the nominal RMS voltage at the power frequency, and lasting for durations of a half to one cycle. Next are short interruptions. These are total interruptions of electrical supply for durations from a few milliseconds to 1 or 2 seconds. Then you have long interruptions. These are total interruptions of electrical supply for durations greater than 1 to 2 seconds. Next, we have voltage spikes. These are very fast variations of the voltage value for durations from several microseconds to a few milliseconds. And these variations may reach thousands of volts, even in low voltage. Next, we have voltage swell. And this is a momentary increase of the voltage at the power frequency outside the normal tolerances with duration of more than 1 cycle and typically less than a few seconds. Harmonic distortion. This is a modern day problem which is developed with the developing technologies where voltage or current waveforms assume non-sinusoidal shapes. The resultant waveform corresponds to the sum of different sine waves with different magnitudes and phases, having frequencies that are multiples of power system frequency. Next, we have voltage fluctuations. And this is an oscillation of voltage values, amplitude, modulated by a signal with frequencies of 0 to 30 hertz. Noise is the superimposing of high frequency signals on the waveform of the power system frequency. And closing with voltage unbalance, we have a voltage variation in a three-phase system in which the three voltage magnitudes or the phase angle differences between them are not equal. Next, I want to talk about the causes of poor power quality. And in today's environment, in the modern world, it's all the devices that we've installed in our plants that are actually causing the poor power quality problems. As you can see from this top graph, modern technologies or the combinations thereof cause the frequency of the electric power to shift out of phase. And these phase shifts result in heat loads within the equipment in the system, leading to their premature failure. And so in the bottom graph, what you'll see there is when you have good power quality, your power will be more in phase. So that leads us to why good power quality is needed. And so, you know, what we want to do is bring your attention back to what is actually happening in your facilities. And so, you know, you should, you know, are you experiencing tripping breakers or UPS alarms, the overheating of your equipment, electrical surges, failures of your equipment, or a transformer failure? So taking a look at the bottom pictures there, these are thermal photographs, and what you can see is that many system failures result from overheating. And these can be caused by many things, but we want to emphasize that heat is your enemy. And this, I want to turn this over to Brian now, who can address some of the existing source solutions.
Thanks, Michael. Let's talk about the current technologies that address power quality. Today, power quality problems are addressed by many older technologies. As an example, devices that provide power factor correction are really capacitance that actually adds THD, total harmonic distortion, to the system. Capacitors correct the power factor. They do not improve or eliminate harmonics problems in a system. Capacitors actually add to the harmonics in a system. Then there are active and passive filters. An active filter uses active components like transistors and op amps for filtering of electronic signals. A passive filter uses passive components like resistors, inductors, and capacitors to generate a signal of a particular band. Both passive and active filters add a load to the system. They're a custom design as a point source static solution. MPTS, in contrast, is a dynamic solution and does not add a load on the system. And MPTS offers multiple technologies in one device. Every great discovery requires someone thinking outside of the box. As we mentioned earlier, Jacobi's law was solved by a professor, researcher, and his team. Adil Khan, this is Adil Khan. Adil is the founder and president of TransPower Company. Initially, his team of engineers developed the idea of using MPTS technology to create one ballast that could be used on 50 different kinds of light bulbs. With the advent of LED lights, the team decided to go bigger with the technology by cleaning up the power for an entire building instead of just one light bulb. After 11 years of R&D, the maximum power technology solution for solving power quality for an entire building was introduced to the world. This picture is of several MPTS H240 units. Each MPTS device has passive filters, power stabilizers, power conditioners, surge protectors, voltage spike protectors, harmonic filters, power factor improvement, power factor monitoring, and that is in real time, and power analysis also in real time. It's an all-in-one device, just like our smartphones are today. And like a bank safe, an MPTS device protects your investments. It's the insurance policy that will ensure that your equipment does not fail. It's the lowest impedance device in the electrical network, so it draws the problems to it. The power irregularities in the system flow into the MPTS. The MPTS technology normalizes those irregularities, and then it reintroduces the clean energy back into the network. Your equipment is now protected from further damage. Michael, tell us about these.
Well, thank you, Brian. So let me share with you the story of Peninsula Plastics. Peninsula Plastics is a CNC plastics manufacturing facility located in Canada. And the owner had a third-party engineer explore the benefits of the MPTS system. And they were looking for, because they were experiencing a number of equipment failures in their plant. So the engineer had heard about the MPTS devices and decided to install one in the Ontario, Canada plant for a test. So looking at this graphic, the bottom sine wave graph shows you the result once the MPTS was installed. Now the top graph shows a sine wave that has a lot of noise in it. And that signal was a result of poor power quality that existed in the system and resulted in numerous equipment failures. So once the MPTS was installed, at the sub-panel where they were experiencing most of the equipment failures, there was a 42% reduction in the volt amps. As well as taking a second look at that lower sine graph, is that you can see that there was a respectful improvement in the power signal. So we at SST and TransPower, of course, believe that this is a great example of what poor power quality looks like, and how an MPTS device will improve the power quality in your system. So this is a slide of the typical power factors of various pieces of equipment that you may have in your building. And so if you have any of these pieces of equipment in your system, you're likely to have poor power quality. In a typical commercial or industrial building, the power factor is less than the DOE mandated 0.95. With an MPTS device installed in your building, the average power factor will always be over 0.95. It is possible for the MPTS device to dynamically correct the system to near unity power factor. And how is this done? It's done by acting like a sink for all the dirty power in that network, cleaning it up, then reintroducing or recycling the clean energy back into the network. It could be considered an on-site renewable energy resource. So what are the benefits of MPTS? Well, there are several case studies where older equipment was going to be replaced, and after installation of the MPTS unit, guess what? The equipment did not have to be replaced. So an example is that in 2013, on a 30-year-old chiller, an MPTS was installed. And that chiller is still running today. So MPTS is also the only equipment that dynamically removes harmonics numbers 3 through 51. So the questions you need to ask are, how much is your repair and maintenance costs annually? How often is your production line being shut down for repairs to equipment, idling your production as well as your workforce? How often does electrical or mechanical equipment fail during a year at your facility or facilities? And how often do you call a third-party electrical contractor to your facility during a year? So I'm going to turn back over to Valerie, and she's going to talk about power quality success story with a commercial office building that had 3 MPTSs installed. Valerie?
Well, thank you, Michael. Earlier, we mentioned that an MPTS provides real-time power monitoring. The following 3 slides will show you snapshots from the real-time dynamic dashboard from 3 MPTS units installed in a multi-story commercial building located in California. It's best to install the MPTS close to the source of the problem. One MPTS unit was installed at an HVAC chiller subpanel, resulting in clean power on that subpanel. The second MPTS unit was installed at the elevator subpanel, resulting in clean power on that subpanel. The third MPTS unit was installed at the main switchgear panel, protecting the building systems from incoming utility power issues. So now we're going to look at MPTS number 1 dashboard. Here we see the snapshot of the dashboard, and it's recording a load power factor at 0.722. That's the second button on the top line. There are 4 banks on this system. 3 are online, indicating OK, as indicated by the green color on the right-hand side. The system capacity is at 91%, as noted in the second green button on the top left row. From the third line from the lower left part of your dashboard, you can see that the load amps is higher than the main amps. So why is that? Because the MPTS is cleaning up the dirty power in the system and recycling clean power back into the system, resulting in lower amps at the subpanel. From the top line of the dashboard, note also that the amps decreased from 305.3 with the MPTS off to 222.7 with the MPTS on. This is a 27% improvement in performance. So now let's look at MPTS dashboard number 2. Here we see the snapshot of this dashboard, and it's at the elevator subpanel, recording a load power factor at 0.95. All 4 banks on the system are operating in OK. The main power factor of the subpanel is improved to 1.0, and the MPTS is at 92% capacity. Notice that the amps decreased from 732.9 with the MPTS off to 696.4 with the MPTS on. That's a 4.9% improvement in amps. So now let's look at MPTS 3, which is installed at the main switchgear. Here we can see recording the load power factor at 0.99 and the main power factor at unity. This MPTS is only at 9% capacity. So why is this? Because the 2 other MPTS units on the subpanels are cleaning up the building power, and at this moment, the income utility power at the main is relatively clean. From the top line of the dashboard, note also that the MPTS amps are almost the same before and after. So why is that? Because the existing MPTS units in the system are cleaning up the power, and at this point in time, the power coming in is relatively clean. So why is all of this important? As you can see, when your power factor is low at 0.50 and your total connected load would be 1,000 amps, and your watts per square foot would be 4.16. But as you see, as you improve your power factor all the way to 0.96, your amps decreases to 601 amps, and your watts per square foot decreased to 2.5. That's almost a 50% savings in your power consumption at your facility. So now I'm going to have Brian talk about some real live MPTS success stories, starting with a citrus fruit processing plant located in California. Brian?
Yeah, this is Porterville Citrus. They produce orange juice for Sunkist. In 2017, 2 MPTS units were installed in their fruit processing plant. The plant had been experiencing many power dips that were shutting down the plant. These unplanned shutdowns greatly affected the plant's output and the plant's ability to produce product on time and every time. During 2018, the local citrus production increased by 25%. They had a bumper crop. But with the two MPTS units installed, there was no increase in the plant's electrical power demand. In 2019, when the fruit production returned to normal, the monthly kW used was reduced by 24.4% over that previous year. PG&E, Pacific Gas and Electric, the local utility, was seeing those high reductions in kW consumed by the plant, thought that their utility meters were the problem, so they changed out the meters. And then after doing some third-party things, they discovered that this was what was really happening. And so PG&E is currently in discussions with TransPower Company and developing a grant program for commercial and industrial users so that PG&E does not have to build additional power generation capacity in that area. The citrus plant owner is also really happy because the TransPower, the MPTS units that TransPower installed caught a overbilling problem that was happening, and now PG&E and the citrus plant are in discussions on how to fix that problem. This right here is where two identical schools were built. They were both K through 8. They're about 2 miles apart in Douglas County, Colorado. They put an MPTS unit in one of the schools and nothing in the other. A one-year study was conducted between the two schools. They're both about 100,000 square feet. The one that had with the MPTS had a peak kW of 206, while the one without the MPTS units peak kW was 282. That's a 27% in peak demand, 27% reduction. Douglas Independent School District, Douglas County School will be installing 80 additional MPTS units during 2020. Here's a story about how MPTS helped a water and sanitation district save on energy. ECCV, which is East Cherry Creek Valley Water and Sanitation District in the Denver area, did a one-year study with an MPTS unit installed in a pump station and also one installed in their office. The power factor in the pump station improved from 0.79 to 0.93, which is a 14% improvement, and the line amps decreased 195 amps from 195 amps to 168 amps. That's a 35% improvement. ECCV will be installing an additional 22 MPTS units for their pump stations in the near future. This next study is actually at NORAD, North American Aerospace Defense Command. In 2012, they were experiencing recurring failures with compressors for air handling equipment. The compressors were a critical part of their plant operations. A 3-month study was conducted in the first quarter of 2012 with one MPTS unit installed on one of those air handlers. NORAD purchased that unit after the study, and in 2017, 3 additional MPTS units were installed on similar equipment within the mountain. 12 MPTS units have been installed at NORAD. During 2020, 13 units will be installed at nearby, it's in Colorado Springs, Peterson Air Force Base. And also, 2 MPT units have been purchased and will be installed at MacDill Air Force Base in Tampa, Florida.
All right, thank you, Brian. So we've learned that MPTS improves power quality. Having a power quality issue means your operating costs and utility demand are higher than they should be. Why? Because dirty power directly from the utility, dirty power from your standby gensets, and dirty power created by all the electrical equipment you have installed throughout your whole facility is affecting your power quality. So MPTS improves power quality. It's about using a 21st century solution versus using solutions from previous centuries. It's future solutions versus past solution. A frequently used past solution is capacitor banks. Capacitors correct the power factor. They do not improve or eliminate harmonics. Capacitors actually add to total harmonic distortion. So if you want to correct your power factor, it makes sense to correct your harmonics while you're correcting your power factor. So today you will want new technologies like MPTS versus using old existing technologies. MPTS is a transformational technology, just like your smartphone. So now let's talk about guidelines on how to size an MPTS unit for your facility. Brian?
Okay, the first guideline is we never size the unit or the units by the size or the rated amps of the panel. We size by finding the kVAR and harmonics of the system. The MPTS units each have a rated kVAR. An H240 can recycle 200 kVAR. An H490 can recycle 400 kVAR. And an H720 can recycle 600 kVAR. So in the second guideline, the rated capacity of the MPTS must exceed the peak kVAR of your system. For example, if there's 1200 kilowatts of kVAR, we recommend either 6 H240s, 3 490s, or 2 H720s. The third guideline is about harmonics. A power quality study is required on the affected network to determine what percentage the harmonics are reaching. Then an MPTS is recommended to meet that need. The example above is from 2012. The consulting electrical engineer installed 10 MPTS units, which just actually matched the size of the panel. A year later, he removed 4 of the MPTS units. The 4 MPTS units were reinstalled in another part of his factory on a different electric panel, because he had determined that only 6 MPTS units were needed to solve the THD problems and to improve the power quality.
Well, thank you, Brian. Now, Michael, tell us about some more of the FAQs.
So thanks, Valerie and Brian. I'm going to talk about 6 additional frequently asked questions. And the most frequently asked one is the sizing of the units again. So we just want to reemphasize that the MPTS H units are sized to match the kVAR of the sub-panel amps, being 200, 400, 600 amps, and also that it's 3-phase, 480 volts AC. Next is we often get questions on training, and so their training can be on-site or online for a reasonable fee. Oftentimes, there's a request for a certified MPTS person to be on site for startup and commissioning, and that can be available at $3,000 per day. This is followed by maintenance. In maintenance, the good thing to know is that the only maintenance is really required is for the fans, which is replacing the filters, but also for tightening loose connections. But unless there's a catastrophic event, that's all that's really expected. Certification is that just know that all MPTS-H units use off-the-shelf UL certified parts, and they're tested during assembled as an assembled system to UL standards. And delivery can normally be expected 16 to 20 weeks after receipt of the purchase order. I'm going to turn it back over to Brian to talk a little bit more about installation issues. Brian?
Okay. All right. To maintain your manufacturer's warranty, installation and maintenance must be done by a certified electrician. The cost of installation depends on the difficulty of the install. Typical install is between $3,000 and $5,000 per unit, but it could be up to, say, $10,000 a unit. Cost depends on the size and the number of the MPTS units. Generally, a return on investment of 3 years or less can be expected, and that's based upon reductions in electrical demand and electrical consumption. Now, ROI can be realized sooner with lowered overhead costs, such as fewer equipment failures, fewer repair calls, and extended equipment life. Installation is always upstream of the load and within 30 feet of the load panel. This is a typical schematic showing an MPTS installed at the main electrical panel. Note that the current transducers, that's the CTs for the MPTS, are the only load at 5 amps and are installed upstream of the panel loads. Here, the MPTS is installed before the main electrical load panel with a disconnect between the load panel and the MPTS.
Well, thank you again for joining us for this presentation on a dynamic, real-time 21st century solution for solving power quality issues in your facility. We welcome your questions and the opportunity to show you that an MPTS in your facility will solve your power quality issues, will reduce your energy consumption, and will improve your cash flow. So please feel free to contact any of us so that we can share more with you about MPTS. Thank you.